Hi, this is Ryan, and you're watching my tutorial on Java. In a moment, we are going to build an entire application from start to finish, and I'm going to be with you typing it out and explaining how it works the whole time. Now, this video is a free complement to my course, Working Class Java. I prefer to teach people by building things because that's mostly how I learned. I don't have a degree in anything. But I want to make sure you have answers to questions like, when exactly do I use an interface or an abstract class? Is there really such a thing as the perfect software architecture? Chances are you want the answer to that question because that is the most common question I have been asked from the thousands of people that I have taught over the years. So, in this video, we are going to write code and solve specific problems. I will include overlays which will point you to lessons in the course which explain in simple language, and I do mean that, virtually every concept from absolute beginner to things which even senior Java developers are not sure on. Believe me, if you make it through these two learning resources, you will have everything I wish I had as a beginner. All I ask is that you follow along with me during the practical lessons, even if they do not make sense at first. Sound fair enough? Great. Let's get started. I don't care whether you are a UI, UX designer, an app developer, or a database administrator. Every app you build starts with some form of problem domain analysis. Problem domain analysis, which I discuss in detail in Working Class Java, can be summarized by asking two simple questions. What data does my app need to represent? What problems does my app need to solve for its users? In this lesson, we will build the first few classes for the Sudoku game. These classes are very much like the foundation of a building, as we will build the rest of the application on top of them. So I've created a new project in IntelliJ IDEA, and I'm just going to correct the package name here, and we'll delete the sample fxml file. That's one way in which you can build a user interface in JavaFX, but we're going to do it programmatically in Java instead. Yeah, we won't need that controller class, and also we will work on creating the main class properly in a different video when we talk about application containers. So what we're going to focus on in this video, like I say, is the classes within the problem domain. So the first one we're going to build is just a virtual representation of a Sudoku game, as you can see here. So this thing here, GameState, is actually going to be an enum that we will create in the next lesson. It represents different states of a game. My code's usually pretty easy to read. I represent the actual Sudoku's grid, the puzzle itself, as a two-dimensional array, as you can see here. And this is actually just a constant, which I use throughout the application. You'll notice that I forgot to write int. I will fix that eventually, but yeah. 9, of course, represents the number of squares in a Sudoku puzzle. Now, I'm hitting Alt-Insert here, and that's allowing IntelliJ to open up a dialog to generate my constructor and some getters. For the getter for the grid state, I'm actually going to make it sort of immutable, and what I mean by that is we're not actually going to just return grid state here. We're going to return a copy of grid state. A little mistake there. How I'm going to do that is we will eventually create this class called SudokuUtilities, which has a static function or method, which will create a copy of that given array. This basically protects this Sudoku game object from being messed with or changed over time. And then we're also going to add implements serializable here. This is just so that I can read and write this particular game data file to a file on the operating system easier. We'll talk about all that later, and there we go, fixing the mistake there. So the next thing we're going to build is a little class here called coordinates, and it's just going to contain an x and a y value, and some interesting functions which we will use with our HashMap implementation when we write the user interface. By the way, there's a whole bunch of things going on here for beginners. You see private, you see final, you see static. I talk about all of this stuff in working class Java, so do consider checking out the course. So we're just going to make a constructor, and some getters would be useful as well. And then we're going to also add in some functions. Now, or whenever I say functions, I mean methods. Every other language basically calls them functions. So what we have here, this equals method, comes from the object class in Java, which every class extends from object implicitly. And the reason why we're doing this is we want to be able to store these coordinate objects in a hash map. We're actually going to basically be using them as keys to keep track of different UI elements. Anyways, I'll talk about that more when we actually get to it. Got a little reference to some Snoop Dogg here. This and that. It's like this and like that and like this and Sorry, I apologize. I grew up on gangster rap. Alright, so yeah, nothing super interesting going on here. Just a whole bunch of boilerplate code. Do try to follow along because as you can see here, I'm not copy and pasting anything, and it is my intention that you follow along with this tutorial. Now, the other thing we're going to implement is a hash code function. So basically what a hash code is, it's kind of like a unique identifier, which is generated from some kind of data that you give it. So what we're going to do is we're just going to take the x and y value, and we're going to use this objects.hash function. And what that's going to do is it will generate a unique identifier from the specific x and y value of the specific coordinates thing. Like I say, we'll see more about that later. And then you might be wondering, why am I creating an interface here? I actually decided on this interface during my problem domain analysis stage. A cool way to use interfaces is to design parts of your application up front ahead of time. This is called design by contract or code to an interface or whatever. Also, I'm anticipating I/O exceptions because this is an I/O device. And yeah, this is just basically read and write. Nothing else going on here. If you're wondering about interfaces, I go into great detail in them in part 4 of my course. That's all for now. As discussed extensively in part 2 of Working Class Java, we can ask a few simple questions about our data to best determine how to model it. Two great tools for modeling data, which does not change throughout the runtime of the application, are static final variables and enums. The GameState enum is rather self-explanatory. It basically represents different potential states that the game might be in. So we have complete, active, and new. And we will see in later parts of this tutorial or lesson series here where that kind of comes into play. We're also going to make a couple different constants for different messages which will pop up in the application. In this case, this is just going to be a message that will pop up when the user wins a game, and I'll have like a little dialogue, alert dialogue pop up. I'll show you how to do that when we build the user interface. And it's just going to display a nice message here. Congratulations, you have won. New game. And we'll also do a quintessential error message here. Always good to let the user know that an error has occurred. Also took me a minute to remember how occurred was spelled. And there's only one thing left to build, which is another enum. This time I actually just select enum there. And this one's called rows. All this is for is legibility concerns, and you will see how that helps us way later on. That's it for this one. Every application needs an entry point. We will now set up an entry point for our Sudoku application in JavaFX. Now we're going to rename this class main here to SudokuApplication. And you'll see in a minute we'll actually create a new main class. Now this main class here exists purely for convenience to be able to actually launch this application from IntelliJ IDEA. The reason for it is that if we try to actually just launch our Sudoku application, then there will be a crash. So what we do is we invoke from here first, and then in this main method, we will actually call the main method within Sudoku Application, which we will see in a minute. But this is purely for convenience sake. Some lightning fast typing skills here, eh? So within Sudoku Application, other than fixing some typing errors, we're just going to get set up here. Oh, sorry, didn't mean to yell. So the first thing we're going to add here is a reference to IUserInterfaceContract.view, which actually is the user interface. Notice how I like to prefix interfaces with I, and then I will suffix their implementations with UIImpl, or just impl specifically. So UIImpl will be creating very shortly, which represents the actual user interface. This stage object that we're passing to it is basically a simple window which JavaFX gives us so that we can modify it. And the SudokuBuildLogic class, we'll be actually writing that class at the very end. It contains the build logic, which is kind of like what you would see with a dependency injection type setup, the code required to wire things together. Now that operation could potentially fail, so we are ready to catch an IO exception if that does actually occur. Also, I didn't have to actually write the main method in this application class because it was automatically generated by IntelliJ IDEA, but I'll just scroll down to show you. You'll need to have that set up down there in case you're writing this all manually. So the next thing we're going to do is we are going to figure out how to import JavaFX into our IntelliJ project here. So go to File, Project Structure, click on Libraries, hit the plus button, hit Java, and then what you'll do is you'll select the lib folder in the JavaFX SDK. You will have to download that, but that's all we're doing here. Go ahead and click OK, and I hit OK again, and now you can see application has been imported properly and we're all done. Okay, we are now going to build the user interface for this Sudoku game. Please be aware that I designed the user interface ahead of time using InVision. Now, before we get to actually implementing the user interface, I actually like to design it and the class it will talk to using Java interfaces. Now, if you have any confusion over when to use interfaces or how they work, and the same goes for abstract classes, I explain this very clearly and very simply in working class Java. And I really mean that. I don't use a ton of words to explain it. It's really quite simple if someone gives just a clear explanation, which is pretty rare. Anyways, so what we've got going on here, as you can see, I've actually nested the EventListener interface in the IUserInterfaceContract. Basically what I'm doing is I'm using the parent interface as kind of like a namespace or a way of differentiating different interfaces. So if I had multiple different user interface components or features, this is how I would differentiate them, because most of them would have like an event listener and a view, and then the IUserInterfaceContract kind of points to which part of the application or the UI that we're talking about. So it's kind of a handy little trick there. The event listener will be something like a controller or a presenter. I like to name things based on what they do because typically that's the best kind of name you can give something. As for the view, anyone who's familiar with three-layer software architectures will know that that is basically a name for some kind of part of the application which binds to the user interface. That's typically what it means anyways. I also talk about three-layer architectures a whole bunch in working class Java, including answering the age-old question that I get asked all the time, which is the best architecture? Is it MVVM, MVP, MVC? And there is an answer. It might not be the answer you like, but I think I have a pretty good answer to that question. In any case, I explained the fundamentals of all the different types of architectures, preferences aside. Now do notice I wrote a capital message in show dialog there. I will fix that eventually, but that was a little mistake. So what we're making now is basically a special custom text field. So text field actually comes from JavaFX. Just be careful when you're importing these things that you're not importing the Java AWT. That's a different UI library that we're not using. So the purpose of this text field is, all it does is it maintains an X and a Y coordinate, essentially, or just a value. And there's another purpose, which is that, as you'll see in a moment, by the way, I'm going to use code generation pretty heavily here because this is just not the kind of thing you want to be typing by hand, honestly. If you want to do that, I've mentioned it before, but in IntelliJ anyways, you can hit Alt-Insert and that will bring up the menu. So I'm going to override two functions from TextField, and the reason for this is that if you don't override these functions, then you get kind of strange behavior with, how can I say it, when the user enters a number 0 through 9 into a Sudoku text box, I would get like repeat numbers and just weird behavior. So basically what this does is it makes it so that if the user just hits 1 on a text field, then weird things won't happen and it will just be a single 1 that's actually entered into the text field. Hopefully I explained that right. Now, oddly enough, there's actually a second method which I need to override. We'll see that in a minute. By the way, I'll talk about regex. You can see that square bracket 0 through 9. That is what's known as a regular expression. You're going to want to look that up and know a little bit about it. It can be really ugly to write, but it's basically a way of matching strings. So what that means above is we're saying if the string S matches any of the numbers 0 through 9, then that expression will evaluate to true. Regex can get really ugly, but it's basically just a way of matching text and stuff like that. There's other ways you can do this, but regex, although it's annoying to write sometimes, it's usually pretty handy in that way. This is the other function. For some reason, I needed to override both replace text and replace selection. And if you're wondering about the super keyword, that basically just calls the method which I overrode from the parent class. Okay, so now we're going to build the actual user interface here. Now, this is going to take a long time. User interface code very often is quite tedious to write. And for something like a Sudoku game with so many different UI elements, that certainly applies. So we're making it extend the view interface that we just created. Event handler and key event come from JavaFX. So that's actually how we listen for input from the keyboard, from the user interface. All I did there is, again, I clicked on the red text and I hit Alt-Insert and then selected generate or implement methods from the interfaces. So again, I'm just letting the IDE do some of the work. So what have we got here? So stage comes from JavaFX again. It's basically like the window, the background window for the application. And group is somewhat like a div if you're coming from like an HTML background, a view group if you're coming from an Android background. It's basically just a container of some kind. Now here's an important question. How do we keep track of 81 different text fields? Now I'm going to demonstrate the wrong way to do it, or a very tedious, verbose, awful way to do it. One way you could do it is you could have a reference variable for every single text field. So basically what we would do is, oh, a little bit of an error there, my apologies. Something slipped through the editing. Basically we could do it like that, 1, 2, 3, 4, all the way up to 81. That would be an awful thing to do. It would be incredibly verbose. So I had to figure out a way to keep track of these 81 different text fields without doing that. So what I settled on doing was using a hash map. Now, if you've been following this in order, you'll know that I overrode the equals and hash code functions for the coordinates, and you'll also remember that the Sudoku text field that we just created has an X and a Y value. So I'm going to store references to all of these different text fields within a hash map, and we're going to use that hash function to retrieve and store them. So you always want to be keeping an eye out for things which are just more elegant solutions. Now, This EventListener class is going to be like the controller or the presenter. So this is what we will pass events, which the user causes or propagates to, and the listener, which is basically a control logic class, I call it, will basically interpret those events and pass messages between the view, the front end, the UI, and the back end. So there's just going to be a little bit of boilerplate style code here. Now, one thing in particular, because this is a single, this application only is a single feature, I'm including the style information in the user interface here. If this application had multiple different UI screens, I would not put it here. I would put it in a separate file and make these things basically either protected or public access, so that I'm not basically redefining them in multiple different user interface implementations. But yeah, they're just stuff that I use to build the user interface how I want. So window Y and window X dictates the X and Y position in the screen, like the actual monitor of the operating system or computer. Padding, we'll see that later. It's kind of like the padding between the window and the actual Sudoku board, and the X and Y are kind of again, those are going to be X and Y values within the window itself. And the ones I'm writing now are pretty self-explanatory. I'll of course show some images of the actual Sudoku board so you can kind of get an idea of what it looks like. And I use this string here just for a title. Okay, so we have a lot of work to do here. Now, I think what I'll do next is create the constructor. Just moving handle down to the bottom. That's just to make it look more like the application which has already been written on the side, which I am basically copying from. And if you're wondering why I'm copying and doing voiceover, it's just a lot easier for me to teach and do that at the same time. Also, I am not trying to go through this super quickly, in case you're wondering why I'm moving so slowly. Okay, so this is a constructor, and we assign our stage, we create a new group, and then we create our hash map. And then once that's done, we jump immediately into a helper method. I don't want my methods to be any larger than they need to be. This is actually something I go into in part 5 of Working Class Java, which is how to think about software architecture in terms of methods, which in a sense just avoid giant methods by using lots of helper methods is what we're talking about here. So what I'll do is, for every kind of user interface component in this particular screen, I'm going to create a helper method for it, and then obviously within that helper method we will actually create it. Background, title, Sudoku board, text fields, and the grid lines of the Sudoku board. And so stage show is what's going to actually reveal the user interface once everything has been drawn and configured. And set listener, so what will happen is we'll have our build logic, which we'll write in just later on, basically assign our control logic class, which is again like a controller or a presenter, to this particular view. Obviously it'll be through the interface. And yeah, here's where we get to the interesting stuff. So like I say, this is going to take a while. Doing user interface code is very often quite tedious. So the first thing we'll do is we'll draw the grid lines of the Sudoku board. These aren't especially in top to bottom order. So X and Y will be where we start to draw these grid lines. And obviously, so as you can see there, basically we're going to be drawing the grid lines, and just notice that some of the grid lines are actually thicker than the others. So the ones which separate the different squares are thicker, and that's where we get this: if index equals 2 or 5, we want the thickness to be a little thicker. Great. All right. So when we want to actually draw these lines, we're just going to use the rectangle class from JavaFX. And what we'll do is we'll draw what's going to happen in this while loop is we will draw each line. We'll do the vertical lines and also the horizontal lines. And obviously we'll implement this getLine method in a minute. So if you're kind of wondering about what we're doing with the X and Y, etc. So we're basically drawing a line and then moving it over by 64 pixels or units, whatever the units are. And then we will multiply that by the index, and then the result will be basically a series of grid lines. Now, the reason why I created this grid line method here, getLine, is that you'll see in a minute we'll also draw a horizontal line. And one thing you really want to look out for, and this is again something I go into in working class Java, is you want to look for repetitious code. So originally I had this code for both the vertical and the horizontal lines in the previous method we were just writing, which we'll get back to in a minute. And then I realized, hey, that's basically the same code, except the only thing that changes are some of the variables. So whenever you see that, that's usually a cue that you want to pull that code out into a helper method, and that will reduce the number of lines of code in your project and just make things more legible because you're breaking things down a lot better. And all that's going on here is we're basically just creating and styling a rectangle, and remember it's going to be a line even though it says rectangle. And there is a plane flying by in the background if you hear some background noise. A little mistake there. Okay, so that's the vertical line, and then what we will work on next is the horizontal line, or lines I should say. And so all we're doing here is it's basically the same code. We're just going to swap around a couple of the parameters here, arguments I should say. And that will give us our lines which are drawn horizontally instead. Okay. All right, so this is how we actually add these UI elements to the root, the group, which is again kind of like a view group or a div. And this add all function means we can basically slap any kind of UI element in. I think the root, the superclass of the UI elements, I think it's called a node. And so we can add anything which is a child class of node. Don't quote me on that. I'm going off of memory there. And now we're going to draw the text fields. So this is going to be kind of interesting how we do this. So it's going to be a bit of a similar setup. So we're going to have like an X and Y origin. So X and Y delta means the change in the X and Y value. And what we'll do is we'll keep drawing these things in increments of 64 units apart from each other. You're probably wondering, what is that ON squared runtime complexity? So I don't actually go into detail about this. I mention it in working class Java. This is an advanced topic here, which has to do with data structures and algorithms. But I just wanted to mention this. This is really important, especially for the beginners listening. But honestly, anyone who hasn't studied data structures and algorithms or runtime complexity, what does that mean? Oh, there's a bird chattering in the background. Sorry about that. So whenever you're using certain patterns or structures, so here we have a nested for loop. We have two loops nested within each other. Now, whenever you do nested loops, especially if you're doing like more than two, what's going to happen here is you want to be very careful doing that. In this case, it's fine because we're only looping 9 times 9 times, so that's where we get that n squared. I can't give you a whole introduction to runtime complexity right now. But basically, if you have nested loops, and there are different things you can do other than nested loops, but that's a really easy example, you do not want to be working with large indexes, large numbers of elements. And the reason why is that the runtime of the application will basically grow exponentially, quadratically in this case, relative to the number of inputs here. So anyways, if you want to learn more about that, you can look up runtime complexity and big O notation. So this style Sudoku tile method here, again, this is just to pull some code outside into a helper method. So I just wanted to take the code which is responsible for styling a Sudoku tile and just put it in a different helper method. Like I say, this just makes things more legible. In this particular case, it doesn't necessarily reduce the number of lines of code, but it just makes things more organized and legible, and I'm a big fan of organization and legibility. Of course, this is how we set the font in JavaFX. Layout X, again, that'll be like the X and Y where the particular UI element will be drawn relative to the window, I believe in this case, or the stage, I think they call it in JavaFX. The text fields will be 64 by 64, their size. And this background empty is going to make them transparent. The background will be supplied by the Sudoku board, which we'll deal with later. So this is how we actually listen for inputs from the user. Set on key pressed. So you'll notice again, this UserInterfaceImpl class implements the, I believe it was the EventListener or event handler interface from JavaFX, and so that is exactly where we set that up. So we're passing this, and the reason why we're allowed to pass this is because this implements event handler. Text field coordinates is our hash map. Every time I draw one of these text fields, I add it to my hash map, and I use a coordinates object as the key. So when we use the put function, it supplies a key and a value, so the coordinates becomes the key, the text field reference becomes the value. Now we're going to draw the Sudoku board, which is pretty easy. It's basically just a colored rectangle. Of course, when you're doing user interface code, rarely is anything really easy. Obviously, you've got to set the X and Y values and the width and the height and this, that, and the other. Not to mention the color. Normally I have code completion on, by the way, which is a lot quicker. You might also notice me making lots of kind of little typing errors. Part of that is because I have code completion on. Also part of that is because I have relatively large fingers and I was born with hand tremors. So typing is, I can type really fast, but sometimes my accuracy is not the best. And in this particular case, I'm looking on the screen off to the side. Most of the time I'm typing, so that's why there's so many different errors there. It's also because I suck, but yeah, just thought I would give you some excuses in case you're wondering. Okay, so text, obviously this is just going to be the title, which goes below the Sudoku board that says Sudoku. I believe set fill actually sets the font color. It's not immediately obvious, but that's how you do that. And again, we're going to add that particular UI element. You're going to see root.getChildren.addAll. In this case, I just have one element. Okay, now the background is the kind of turquoise colored background. Scene is, again, I think it's something kind of like a view group. It would basically be like the background of the background, or something equivalent to that. And so just a quick point here, you'll notice that I'm using very few hard-coded values. Yeah, there are a few, like I could make the font size a hard-coded value, but I'm using a lot of static final constants, and that just makes things more legible, and it's also slightly more efficient. When you really get down to it, computers are so fast right now that certain things like that won't cause a huge it's not necessarily going to make things a whole lot more efficient, but it's good to get in the habit of using the more efficient approaches. But for me, legibility is a primary concern, and that's why I'm not afraid to use things like enums when appropriate. So for update square, this is what will eventually be called when I just want to update a single square after the user has input a number. Rather than having to update the whole board, which we do sometimes, we're just trying to update a single UI element appropriately. I kind of took that cue from messing around with React JS, in which it's kind of like a web platform for building user interfaces, and or framework, I should say. And it's neat in that it'll only update the UI elements that need to be updated instead of redrawing the whole thing. And so text property.setValue, that's going to set the actual text input that the user gave, a number from 0 through 9. Update board will wholesale update the entire board. So that would occur when the user finishes their game or something like that, starts a new game. And I forgot to copy the for loop, which was kind of silly. Like I say, you've got to understand that my eyes are glued to my secondary monitor while I'm typing most of this stuff, so there's going to be lots of little mistakes like that. So for each text field, we're going to grab it from the HashMap text field coordinates, and I can grab them by creating a new coordinates object with a particular x and y value. And the nice thing about the hash function, which we talked about earlier, is that I basically can recreate it anytime I want. As long as those values are the same, it will create the same hash value, which is quite handy. Obviously, get copy of grid state creates a immutable copy of the game, which is kind of important. I do talk about immutability, which is a big word for things which don't change extensively, and that's a really important topic especially if you're like an intermediate developer. It's a really great way to make your code more resistant to bugs and changes and all kinds of things here. Double equals error. Now, you'll see the if value equals 0, I set the text field to just be empty. Basically, 0 or backspace represents kind of like a deletion thing. So I had a little error. What happened was GameState, which is an enum we created, wasn't actually imported in my Sudoku game. So just importing that fixed it. So what we're doing now is we're checking if the value either equals that empty. Okay, so actually let me backtrack a bit. So what we're doing here, so this function will basically be called when a new game is created. So you can see this GameState.new. So what's going to happen is if we have an empty square, so if value.equals blank, then what we'll do is we want to enable that text field and set it to a slightly less thick font. That was really annoying to do in JavaFX, so I finally actually had to resort to using a bit of CSS here as what's within those quotes. If the number is already colored in, I don't want the user to change it, so we set disable to true, and we also set it to a slightly, sorry, I said thicker, it's opacity, so opaque, which would be an alpha value if you're familiar with alpha. Transparency is what I'm saying. Now that that's done, we have the show dialog. So this will get called when the logic center of the game logic, indicates that the game is actually completed properly. And then what we'll do is we will show this alert dialog, which will, there I correct that message thing there. We show an alert dialog, which basically will ask the user, hey, congratulations, you won. Do you want to start a new game? And show and wait will basically pause things and wait for interface or interaction from the user. Once that occurs, we can tell the listener, hey, on dialog click. The dialog was clicked, the user wants to start a new game, and then the listener will figure out what to do at that point. Now, if there's any kind of errors that occur, so there can be an error which occurs when we either write or retrieve, read or write the game state from storage. So if any of those errors occur, then we just want to let the user know, hey, something went wrong. Finally, over the handle function, again, this comes from event handler, which is the JavaFX interface. So this is where if the user enters a number into a text box, that event will pop up here. And what we're doing is we're checking the event type and we're saying, okay, was it a key that was pressed? Because I don't really care about other events like mouse clicks and things like that. That's just noise. If that event matches, so here's a funny thing. I'm using regex here. As I was recording this code, I had this giant if statement full of or statements for the numbers 0 through 9. And I was looking at that, I was thinking, didn't I just use regex to do this exact thing? So I actually added this in immediately, the regex, and that just cleaned this method up a whole bunch. Usually there's very often a more elegant way of dealing with things instead of the brute force method. So value is whatever the user has actually entered when they entered a number. Source will be the UI element, the variable, the object that was actually clicked on. So that's why I'm going to use the event.get source there to pass that reference in. It will get passed to the handle input function method, I should say, as an object, a Java object, like the class. And we also check for backspace. If it's a backspace, then I want it to be treated like a 0, essentially. So that's why we're passing in 0 there. So if the user wants to like clear an entry in the Sudoku or clear a Sudoku square, they can either hit 0 or backspace. I think that's just like a generic thing. If the user types anything else, then we just set it to empty. I just want to avoid writing numbers and stuff like that. Event.consume, as far as I know, what that will do is it will just basically once the event gets consumed, then it's not going to propagate through the rest of the application. That, like the internal code within JavaFX or any of the other stuff. And then again, we're going to let once the input occurs, we're going to actually pass that input to the control logic class, which is the listener here. And we're going to say, hey, at this X and Y value, this value was called. Okay, so we're now going to code the control logic class, which is again kind of like a controller or presenter. And it basically manages the interactions between the user and the user interface and the back end of the application, which would be like the computation logic. So it's going to extend the EventListener interface, which we defined in the previous lesson or video. And again, I'm going to hit Alt Insert, and that'll bring up that dialog where I can implement the abstract methods. Now, just an important note here, whenever you're dealing with like a controller or a presenter or a view model or whatever, I strongly recommend that you communicate, at least with the back end here, I communicate with the view as well, the front end class, through interfaces. If you're not going to use interfaces anywhere else, use them across very large and important architectural boundaries across your application. This is very simple applied solid principles, and it's just a really important thing to do. A lot of people think it's a waste of time, and I respectfully disagree, because the other thing is that it helps me to design my application up front without worrying about the implementation. And if I need to change the storage implementation, I can change it quickly and easily without having to cause any issues in this control logic class. So what we're doing here is when the user basically inputs a number, what we're going to do, or deletes a number, we're going to write that to the game storage. And the reason why we're doing that is we kind of want the game storage to be like the source of truth in terms of the actual game data. Now that can potentially fail. It hasn't yet, but you just have to be aware that when you're using something like a input-output system, you want to code. You want your code to be capable of dealing with any errors that might pop up. Otherwise, you're a bad programmer. Just saying. Now, if that writes successfully, then we create a new Sudoku Game object. The reason why we create a new one is I've designed it that way. It's an immutable object. And this is actually how you work with immutable data models, is you create a new one from the old one. Once we've successfully written to the storage, then we can update the view. And again, like I said in the previous video, if we don't need to update the entire user interface, if we can get away with just updating one square, that is a very much more preferable way to do things. So now what we're doing here is we're just checking to see, okay, is the game state complete? And that will be dictated by the code that we'll be writing in the next video. And if it is complete, then we want to show a dialog to the user. Now, if for some reason something does go wrong, which is unlikely, there's not a whole lot we can do beyond showing an error. So that's what we do here. And this will obviously show like a dialog to the user. So we can at least let them know that something's gone horribly wrong. And if the user clicks the OK dialog, then this is where we will handle that, and this will generate a new game for the user. And again, we're going to immediately update the storage first before we update the user interface, because the storage is the source of truth. We'll be writing the GameLogic class in the next video, and that video is also going to take a little while because it turns out it's actually pretty complicated logic to implement a Sudoku game. And once that works successfully, then we will update the view. Notice how this is kind of a more functional style of coding, at least in the try block, and as functional as Java can be. Okay, we're now going to write the computation logic of the application, and this will take a little while, so buckle up. So originally I just had a single class here which encapsulated all of the what I'll call computation logic, called GameLogic, and then as I went through actually implementing the logic required for the various steps to basically administer a Sudoku game, I discovered that there was a lot of different steps involved, and I broke this logic down into a number of different classes. Now, the first one here we have is just like a utility class, SudokuUtilities. So what it'll do is it has a utility function, a static function, which will copy the values from one Sudoku array that's passed in, one two-dimensional array, into another two-dimensional array. And then it also has a second function which will take in an old array, and it will return a new array with the same values. And you'll see that's kind of used in a couple different places in the backend logic of the application, and also in the Sudoku Game data model itself. Now, before I proceed, I need to explain something really important about the usage of static functions here in this part of the application. Static methods, I should say, in Java. So something that I go into great detail on in working class Java is how and when to use static methods and static variables, and what exactly static means. Now, I can't explain it here because I need to actually explain a little bit about how memory space works, in particular the JVM memory space, in order for you to really understand how static works. I do go into great detail about that in the course. Now, what I will tell you here is a little bit about how to use them safely. You're going to notice that I use static methods extensively in this part of the application. Now, the important thing here is that I use them in such a way to avoid what in functional programming you would call side effects as much as possible, what I might call shared mutable state problems. So what that basically means is that these static functions are only going to reference and deal with either parameters that are passed in, so for example old array here, or variables which are created within the method body of that particular static function, and they can also call other static functions. Methods, I keep saying. Whenever I say function, imagine method. Now, what we basically want to do is the way I'm using static methods here is almost like I heard someone else say a poor man's version of functional programming, but that's kind of a little bit accurate. It's about as functional as you can get on Java. So anyways, I could go into a lot of detail here, and I do in the course, but I just want you to be aware you need to be careful when using static functions. Some people hate them. Some people say they are horrible and the Antichrist. I don't think those people really understand what they're talking about there, but there is definitely some truth that there are ways you can use static functions which are really bad and can make your code difficult to test and all kinds of things. So as you can see here, again, we're going a little bit functional by having these nested method calls. So the first method we have here, getSolvedGame, will generate a solved Sudoku game. This is going to be a little bit complicated. This first algorithm here to generate a solved game was made entirely by me. We'll see later on there was another algorithm which I did not create, but this particular algorithm was made by me. Now, the reason why I did this, it's not necessarily going to be the most efficient algorithm. In particular, later on, I want to actually rebuild this algorithm as a graph coloring problem, which that would be like an advanced topic in data structures and algorithms. But I wanted to do something which was hopefully as easy as I could make it for a general kind of programmer to follow along. Now, I'm not saying it's going to be easy, but I'll do my best to kind of talk you through it here. So the basic idea here, first we seed a random number generator. That's what random is. And then we, of course, we create a new grid, which will be based on the boundaries here. The grid boundary, which will, of course, be 9. So what we're going to do is for the values 1 through 9, we are going to allocate them 9 times. Of course, every Sudoku puzzle will have 9 1s, 9 2s, 9 3s, etc. So that's what allocations does. It tracks the number of times the number in the given value is allocated. This interrupt is going to basically, this is even a little bit difficult for me to kind of follow along here, but what the interrupt will do is, what we'll see is kind of a backtracking that occurs. So if an allocation is attempted too many times, then we will add, basically, we will increment our interrupt variable. And then we also have an attempts variable here, which works as a failsafe. We'll get to that in a minute. So what we're doing is we're saying, okay, while the number of times we've allocated a particular number, so for example 1, is less than 9, keep attempting to allocate that number. If the interrupt, that is the number of times we attempt to allocate a number, is greater than 200, or sorry, I think I'm mixing that up a little bit here. Yes, okay. So if we make more than 200 attempts to allocate a given number, so for example 1, then what we do is that allocation tracker thing is basically just a list of coordinates. So each time we will allocate a number, we will add that to our allocation tracker. So what we're doing here is if interrupt is greater than 200, then we want to go through the past numbers, 9 numbers or whatever numbers we've allocated, and we want to reset them to 0. So basically, in simple terms, we're backtracking. If we get stuck, i.e. interrupt is greater than 200, we backtrack a little bit and we say, okay, let's just reset to 0 and let's try this thing again. Now, it turns out that is not enough. It's possible that even doing that we can just get stuck and this algorithm will run forever. That's why we have the attempts tracker as well. If attempts is greater than 500, we are definitely stuck, and what we do at that point is we clear the whole array. We basically nuke everything and reset it all to 0, and we try again. So this is actually like a 2-stage backtracking algorithm. We're writing a little helper function here, clear array, which, like I say, it's just a simple array traversal, and it'll reset every element in the 2-dimensional array to 0. So as you can see here, it's there's a lot of stuff going on. Like I said before, there's actually a way to model this differently using a graph data structure. So that's something that I would like to do later on. But the thing about that is it's going to require a certain amount of explanation and practice. And I haven't actually solved the problem yet myself, so I'll need to do that first. But hopefully, now that I've talked you through what's going on here, it should make at least a little bit of sense. And like I say, it's not necessarily the most efficient algorithm. That wasn't really what I was going for. I was trying to make it as legible as possible. Now, what we do is each time we're about to allocate a number to our 2-dimensional array, we randomly select a square. by using the random number generator here. So give me an x coordinate that's random, give me a y coordinate that's random. Now, if that particular grid location does not equal 0, or if it equals 0, we will now randomly, or not randomly, we'll now allocate a value to it. If it doesn't equal 0, then we just want to skip it because that number has already been added in, so we don't want to overwrite the progress that we have already made. Now, what we're doing here is once we allocate a value, we actually immediately check to see if it's a valid or invalid Sudoku game. We'll write the GameLogic class shortly, well, at the end of this particular section. And so if the Sudoku is invalid, then we want to remove the value we just allocated, and then we are going to add we're going to increment the interrupt tracker. Otherwise, if we did just update a new square with a valid value, then we want to add that particular allocation, that number, to our allocation tracker. And that's, again, just to help with our backtracking if it becomes necessary. Also, we want to add to our increment our allocations. And if all that works, we return a new grid. Now that that's done, we can work on the unsolve algorithm. So this was a really interesting thing to work on. So I wrote the unsolve algorithm, but there's kind of an interesting problem here. How do we actually know if a Sudoku game is solvable or not? So when I was writing this unsolve algorithm, I thought to myself, okay, what we'll do is we'll just randomly pick 40 numbers from the Sudoku game and we'll just remove them. We'll set them to 0. So initially I thought that probably would make Sudoku which is solvable. It turns out that was not the right intuition at all. It's entirely possible to randomly remove 40 numbers and create a puzzle that is not solvable at all. So this poses a very interesting problem. How do I create a Sudoku puzzle that isn't solved, hence unsolved game, that is still solvable? Well, what I ended up having to do is, so first we do remove 40 numbers from the Sudoku game that has already been solved. So that's why we pass, you'll notice, whatever returns from getSolvedGame will basically be piped immediately into unsolvedGame. So also the reason why I'm using SudokuUtilities here is I don't actually want to work on the original object for solvedGame, and that's why we're using the copy Sudoku array values. And this is something you want to be careful with if you don't really understand Java memory space, which is something I explain extensively in Working Class Java. How reference variables work. Anyways, so what we're doing here is we're removing 40 numbers from the two-dimensional Sudoku grid. That's the first step here. And similar idea, we just randomly pick 40 numbers. You'll notice I want to write solvable with an E repeatedly in this particular video because for some reason solvable sounds like it should have an E. Oh, English language. So what we're doing there is we're just checking to see, did we already remove the value there? As you can see, I completely screwed that up. Again, I don't know how I missed that in the editing. Well, whatever. I'll admit editing is not my strong suit. Okay, that's a little bit better. So if it does not equal 0, then we set it equal to 0. If it does equal 0, then we just loop again without incrementing index. Just making sure I'm in the right bracket here. Okay, so we remove 40 values from our Sudoku puzzle. Now, the next thing we need to do after we've removed those values is we actually need to solve the puzzle again, or at least attempt to solve it. So this was actually kind of a big deal because it's actually not as easy as you might think to solve a Sudoku game. It's not the most complicated algorithm that I've written. I think probably writing red and black trees was pretty complicated for me. That's a complicated data structure. But yeah, so we're going to create, again, an immutable copy to be solved, and then we're using that copy function. And then we're going to use this SudokuSolver class, which again has static methods, to actually check to see if this puzzle is solvable. We pass the puzzle in that we just removed the 40 values from, and then we want to see that class there, SudokuSolver, will tell us if it's solvable or not. Then we're going to jump in and go ahead and create that SudokuSolver. Now, just a bit of background here. So the algorithm I'm using to solve a Sudoku puzzle is called the simple solving algorithm. I actually got this from the Cornell University website. There's an article written by, called Solving Any Sudoku. Now I'm not from Cornell or anything like that, but I just wanted to give a shout out that this is where I get this. Now, part of this algorithm was basically doing what the person who made this algorithm called a typewriter enumerate. So what that basically means, it's a big fancy way of saying we take a two-dimensional array and we turn it into a one-dimensional array. So what we would do is, so let's say array index 0 through 8 of the one-dimensional array would be the top row of the Sudoku, and then array index 9 through, oh my poor brain, 17 or whatever the hell the end would be, 18, that would be the second row, so that would be y equals 2, and then you basically just pull out the two-dimensional array into a one-dimensional type thing like that. And that's just a necessary step with this particular algorithm. Now, it's kind of an interesting note to see how this is where data structures and algorithms does actually become pretty important. Because one of the most interesting things I learned when I was studying that topic, and I didn't go to university for this stuff, in case you're wondering, one of the coolest parts about it was you start to see that you can take the same data, the same information, represent it in a different data structure, and that can make it easier or more difficult to solve problems. In particular, I guess a really, really good data structure for Sudoku games is a graph data structure. Anyways, I won't go into detail on that. Now, obviously here what we're doing is we are keeping track of empty cells. And we're going to assume that the maximum number of empty cells is 40, so that's why we're doing if iterator equals 39 there. And so what we're trying to do here is we just want to know which cells are empty. It's quite complicated, isn't it? Now I just want to make another reminder here. So we're using some nested loops here. Again, you want to be careful when you're working with nested loops because they can, if you have two nested loops, you've got a quadratic or a square runtime complexity. If you're using three nested loops, you've got cubed runtime complexity. If you don't know what that is, basically just understand, do not use nested loops when the indexes or index I, I'm not sure, are very large. The number of inputs is very large. How you would say that technically is when n is large. But with the sizes we're dealing with here, it's not really a big issue. So again, we're just checking to see if the actual puzzle is valid at any given point in time. So basically what we're doing here is we are checking to see which cells can't be solved, essentially. And what'll happen is we'll eventually either solve the puzzle or we will hit an impasse where we can't solve the puzzle. I'll be perfectly honest, I didn't actually write this algorithm, and the inner mechanics of it are slightly escaping me at the moment. I think what it is, so we get every empty cell and we test numbers in that particular empty cell. So we'll test the number 1 through 9. And we basically just keep adding numbers to each empty cell. And every time we add a number, we check to see if the puzzle is still valid. And so essentially we're using a algorithm which really just follows the basic rules of Sudoku. It's going to just kind of incrementally go through it. So now we're going to write the GameLogic class. So this GameLogic class, I'm going to be perfectly honest with you. Originally, I assumed I was going to get away with maybe 1 or 2 classes in the back end to encapsulate the game logic. As you can see, things got a little bit more complicated than that. In retrospect, what I would rather have done here is I would rather have created an interface and then spoken to a facade pattern, it's called, and then I would have that facade call the different static methods necessary. Like I say, this was one of those situations where I really just thought it was going to be simpler than it actually turned out to be. Not to say that it's extraordinarily complex, but there's a number of steps involved in getting this thing to work properly. So the result of that is we have this class here, GameLogic, which the first thing I did is I encoded the rules to figure out whether a Sudoku game is valid or invalid. And that part was relatively easy. Obviously, you just see is any number repeated in a row, repeated in a column, or repeated in a square or subgrid, 3x3 grid, rather. And so we have this class here, which is basically doing double duty. It's delegating to GameGenerator, and it is also encapsulating the logic to check whether or not the Sudoku game is valid or not. So That's a bit of a breakage of separation of concerns. So if I could do it again, and I'm probably going to rebuild this application in Android, and I will definitely do a better job with separation of concerns in that particular case. It's not a big deal, but I'm just saying I'm a bit of a perfectionist with separation of concerns, and there is refactoring to be done. So another rule we want to know to dictate whether or not a Sudoku game is complete is whether or not the tiles are all filled. So we can have a perfectly legal, valid Sudoku game, but that doesn't necessarily mean that it is complete. So that's another one of the victory conditions here. Again, I'm going to be making pretty extensive usage of helper functions to avoid just having gigantic functions or methods. The methods were large enough in my algorithms. Now, I mentioned it before, but squares obviously refers to the 3x3 grids. There are 9 3x3 grids that make up the whole 9x9 grid in a Sudoku puzzle. Now you're going to notice something which might seem a little bit strange. So we're going to be checking individual rows of squares. Now, and you're also going to see this rows.top. That's an enum I made way at the start in the constants class or package. Now, the reason why I have this enum here, I don't want you to be confused by it. It is entirely to improve the legibility. How we're going to select for the different squares and different rows of squares in this particular, in the puzzle, is we're going to have to use coordinates, x and y coordinates. Now, just in my case, I found it a little bit difficult to read, and that is why I used enums here to just kind of help remind myself, okay, we're either talking about the top, the middle, or the bottom. Now, I think in a general sense, that is the main purpose of enums, is to improve legibility. There's different tools you can use that are more efficient than enums, but there aren't many that are a whole lot more legible than enums. Maybe like static constants, but in this particular case, the enum just seemed appropriate. What we're going to do here is we're going to check the first, second, and third square in the top row, and then we'll move down and do the middle and then the bottom. Now, if you look up enums in Java, then you're going to see a lot of opinions talking about how you shouldn't use them because they're not memory efficient. I would like to just say for the record two things. Number one, enums have been optimized a lot. Now, the thing about performance is you can almost never really say anything totally concrete about performance because operating systems differ, JVMs differ. Are you working with the Open JDK or the Oracle JDK or whatever? So that's the first problem. Secondly, it's very, very rare that the impact you will have on your program using an enum versus maybe a more memory efficient alternative will actually ever be noticeable or even acknowledgeable to the user. Now, I'm not saying you should use them everywhere and anywhere and make really huge enums all the time, but what I am saying here is if you have read something about how enums are inefficient, just understand these are people who are basically not really understanding the context of the situation. Okay, we're saying they're inefficient. That's very often not true. What you're saying is they might be like infinitesimally more efficient than less efficient than a slightly more efficient option. But what it really comes down to is, does it affect the performance of the application on the user side, versus does it make your code more legible? So what we're doing here is we pick out say for example, the top 3 squares, and we add them to a list, and then we're just going to pass that list to our collection has repeats function here. And what that's going to do is it's basically going to look at each square individually, and it's very simple. We're just going to see, is the number 1 repeated? Is the number 2 repeated? Is the number 3 repeated? Etc. And that's how we kind of dictate whether or not the particular square is valid. Now, 0 can repeat. That's fine. It's just the other numbers that we're concerned about. And this just comes from the rules of Sudoku, in case you're wondering. And we're going to use a handy little function there to make that a little easier, collections.frequency. That comes from the Java standard library. Okay, so now that we've got the top row configured here, we will work on the middle and bottom rows. Now, I just need to point something out here. There is a slight mistake with the X index and the Y index. Those are actually supposed to be reversed. So the 0, 0, 0, the 3, 3, 3, and the 6, 6, 6, those are supposed to be Y indexes, which would indicate the top, middle, and bottom. Again, when you're doing this amount of rewriting a whole bunch of code, there's going to be little mistakes like that. But just understand those are supposed to be reversed. Now, checking for whether columns or rows are invalid is very, very easy. We just look through each row or column in the grid, and we again see if there are any repeat values. Now, this is again something where we're going to see I create another function method called rows are invalid, and the code is going to be very repetitious. And that's actually a sign to me that I should probably apply some abstraction here and basically pull that code into one single method. But unfortunately, that didn't really occur to me until I was busy recording this thing. So it is what it is there. Not a big deal, but again, this is just me being an absolute perfectionist when it comes to abstraction and separation of concerns. And all that's going on here, for every X value, we will add all of the Y values, and we will just check to see, again, using our helper function, collection has repeats, whether or not it is actually valid. And I misspelled collections has repeats, so we'll just fix that there. And then we'll code the function for rows. Now, like I say, this is a place where the code's very repetitious, so that's usually a sign, like I discuss in my course, that there's some refactoring in order to fix that. But yeah, Just thought I would point it out. Luckily, I managed to fix that particular error. That would have been buggy. And that's basically it. So what's happening now is we're just, some of the static functions actually need to be public because they're used in different parts. I could probably make them protected. This was a particular case where I was being lazy about my access modifiers, but yeah. In actual like production code, I would not just leave them public, just an FYI there. Chances are at some point you've heard the term dependency injection, or you've heard about the service locator pattern, and you might have wondered what these things are actually about. There's a more technical word which I really don't like to describe this, but my favorite teacher for software architecture, Martin Fowler, describes it incredibly well. He states essentially that we are applying the principle of separating configuration from use. In my own terms, I would say that an object which uses other objects should not also build those objects. You should pull the logic required to build those objects into a different class or function or something like that, or method, I should say. So that's basically what's going on here. We're taking the logic required to basically wire up all the different actors in our application together just before they launch for the user to use, and we're encapsulating that into its own special little area of the application. And the good thing about using interfaces is that we can use these interfaces within our build logic itself here. Like as you can see, the user interface is being referred to or referenced as its interface. Same with storage, etc., etc. Now, oftentimes we do need to refer to the concrete names when we're creating things, like in new LocalStorageImpl, but yeah, you get the general idea here. So basically what this class does is we attempt to get the game data from storage if it exists. Now, if it doesn't exist, then what will happen is the storage class, which we'll write in the next part, will throw an exception, an IO exception. If that's the case, then all we do is we just ask GameLogic for a new game. We update storage if possible. And then down below here is where we will actually bind everything together. So the first thing we're doing here is we're creating our UI logic class, the control logic class. And that thing requires storage and our reference to the user interface in order for it to do its job properly. Just going to import that. By the way, I'm hitting Alt-Enter to import there. And then we need to, of course, bind the control logic class to our user interface so that they can talk both ways. Finally, we call this method, which will basically update the board with its initial state, and things will start, it'll start the ball rolling. And that's basically it. Okay, so the last thing we'll do is we will implement our storage mechanism. That's often called a persistence mechanism. Persistence just means persisting data, in case you're wondering. That could be referring to something like a database. In this particular case, what we're doing is we're actually just going to be writing a file to the local file system in order to store the data. So of course I have my IStorage interface, which I will implement by hitting Alt-Enter. And we have two methods which we need to implement. Now what we'll write up here is something which is a file type reference variable. Now basically what this is, it can be a bit confusing, but it's more like a path or a URL rather than thinking of it as the file itself. So system.getProperty will retrieve the operating system's kind of home directory, and this child argument here will be the actual name of the file that we store. So of course, in the user's home directory, we will store a file called gamedata.txt. Now we'll use this file object both for storing and retrieving the data, in case you're wondering. So the first method here, update game data, will of course write to the local file system. In order to do that, we will use output streams. So the first stream will be a file output stream. And streams are basically just ways, it's about streaming data either in and out of the operating system, or there's HTTP URL stream in Java if you want to stream data from the interwebs. But yeah, this is the most common way to sort of write files. And we'll also need to create an object output stream as well. I'm going pretty slow here with the typing because there's a whole lot to type here and it's kind of complicated. Now, why are we doing an object output stream as well? So our Sudoku Game class, if you recall, extends a, I forget if it's a class or an interface, but one of the two, called serializable. And so what that does is it basically allows us to serialize that class, which means turning it into like a data format which is easy to read and write. In this case, to a text file even. And that just makes it easier for us to read and write that data. There's other things you can do. You could read and write to a JSON object, but in this case, serializable was the quickest, easiest way for me to get the job done, and that's often a good solution. If for some reason the file doesn't exist, or rather if we try to update the game data and we're not able to, we're just going to throw an IO exception. Obviously the message there is a little bit generic, but I'm not super concerned about that. Now, when we want to actually read the data from the file system, then we're going to use input streams. So it's almost identical, except we're just using input stream instead of output streams. Again, we'll use the game data file as a way of finding our resource. As you can see, it's very, very similar. Now, if for some reason we can't locate the file, generally speaking because it doesn't exist, so if it's the first time the user has run the application, then we will throw an exception. Now, this might be an important little thing to mention here. Exceptions don't always need to be critical errors. You want to think of your exceptions as basically being of two different kinds. So if you're having like a null pointer exception, that's going to obviously crash your application, whereas things like IO exceptions, I'm not sure why I wrote class not found exception. That is probably a typo there. That should probably say IO exception. But if you have something like an IO exception, it might not actually be like a fatal error. It might be just a way of basically using it like a control statement. If it exists, do this, otherwise do that. So okay, I do actually throw the IO exception there, which is good. So anyways, that's basically all we have to do, and then everything will work beautifully. Thank you for joining me in this tutorial. If you would like to learn a lot more about programming and in different languages than just Java, then check out my other tutorials and courses available across the web. I maintain a YouTube channel where I host live Q&A sessions when I can, and I am active on many different educational platforms such as Udemy, Skillshare, and more. This tutorial is dedicated to my friends A.A. Mon, Davor Maric, Darrell Bitsi, Chetan Garg, Jamie Corkhill, Al Warren, and the countless other people who have helped me build my skills as a developer and to share that knowledge with others. Peace out, y'all. I'm outie.